Nearing the end of our journey, future directions. The really major future direction is here already, and that's open science. You'll be pretty familiar by now with these 10 steps. Here they are again. Start off using your ingenuity to explore and pilot test, refine your questions, and state these questions to what extent. Design a study likely to give you good, precise estimates, and then, if you possibly can, pre-register full details, including details of your data analysis plan. Then do the real work of recruiting participants and running your study, following the plan closely, calculate your estimates and make figures with confidence intervals, again in accord with your data analysis plan. Interpret these using your judgment as to what's really going on in the research context. Perhaps have a beer to celebrate finding some nice precise estimates. Then you have the option of exploring further for tentative conclusions or speculative things that might help you design further studies. Report your study fully, whatever the results you obtain, and if you possibly can, provide all your materials and data openly so other researchers can benefit, maybe getting in touch with you and talking about further research or a replication. Think meta-analytically all the way along. How does your research fit with previous studies? How will it lead on to further studies? And perhaps think about running a replication or persuading somebody else to run a replication. Summed up by, do we have the full story? When you're reading research, you're always thinking, do I really know everything? Do I know all about this study? Do I know about all other relevant studies? And when you're reporting your work, you're reporting it in full detail so other people can understand it fully and perhaps do a replication. One of the major motivations for open science has been the replication crisis. Well, how serious is this really? We'd like to estimate the replicability of published research. And one of the first studies to do this seriously in psychology anyway was Many-Labs 1. Here we have the dozen or more findings that were replicated in this Many-Labs project. Some of these go back to 1940, 1950, 1930, and are very well established and well-known findings, all published in excellent journals. Then up to 36 independent labs around the world took part in this project. The X marks the initial finding, and you can see that these are, in most cases, pretty substantial effects, a couple of smaller ones buried in there, but most getting up between 0.5 and 1 Cohen's d. And here we have all the results of the replications. On each one there'd be a confidence interval around it, and here's the meta-analysis of all these results with the vertical bars marking the ends of the diamond, the ends of the confidence interval on the result of the meta-analysis. So in this case, the replications all found giant effect sizes, round about 2 or more. Perhaps there was some subtle difference between these studies and the original, despite enormous efforts to try and replicate very closely. Perhaps the world has changed in the couple of decades since the original result in 1995. And as we look down here, it looks like these original findings tended to underestimate somewhat or largely what we now think are the most precise estimates we have of these effects. Moving down, in many cases, the replications found results, well here, very similar to the original, until we get down to several at the bottom of this figure where the original results are up there between 0.5 and 1, but the replications find quite good agreement that the effect is 0 or really very, very small. This suggests a mixed picture, that there are certainly some cases where results have been published and findings have been pretty well established and accepted, but careful multiple replications show that the actual underlying effect might be just about 0. There's a second big project that really hit the headlines in the middle of 2015. This worldwide project was coordinated out of the Centre for Open Science. The researchers chose 100 studies published in excellent journals in social and cognitive psychology and found labs around the world to replicate each one lab for each. They took great efforts to make these replications as close as possible, and of course they were all pre-registered and carefully reviewed before they started collecting data. And the result was that on average, the replication studies found an effect size just half of the original effect. And that's a massive, in a sample size of 100 effects, to find the suggestion that the published research out there overestimates true effects by a factor of 2. And here's one way to represent the findings. Each dot is an effect, so there are 100 dots, and a single dot, say this one, is plotted to represent the effect size across on this axis of the original study. The effect size measure here is Pearson R correlation, but you can think of it as just sort of small, medium-ish, large-ish, very roughly. So here's an effect that was estimated to be really quite large in the original, but then in the replication estimated to be only about 0.2. It went from about 0.6 or so to about 0.2. Dots that are close to this line up here found very similar effect sizes in the original and in the replication. And dots along this line here represent effects that were first found to be substantial, but then on replication were found to be very close to 0. So very roughly speaking, you've got a third or 40% or something of these 100 studies that seem to replicate and give fairly similar results, and about half or a little more that found substantially smaller results, or even very close to 0 results. Each of these dots you've got to think of as sort of a big blob, because it had probably a substantial confidence interval in the original study, and then quite a sizable confidence interval, perhaps not quite so long, in the replication study. So we can't make too much of any particular point, but overall we've got a very strong result that the replications found, on average, half the size of effect of the originals, which suggests that, at least in social and cognitive psychology, maybe in a big part of the literature out there, that effects are overestimated by a factor of 2, and that really is a very substantial result. The replication crisis does have some real basis, and we do need to work on better ways. Hence, open science. At the end of 2015, Nature, one of the world's top science journals, listed 10 people who mattered this year across all of science. Here they are: climate and embryo and nuclear and archaeology and so on and so on. And on the list is Brian Nosek, psychologist, nicknamed Bias Blaster by Nature, for his project to improve reproducibility in science. So it's not just psychology fixing up its own problems, but it's psychology pioneering the way that science needs to be done better. And Science, the other absolutely top world journal, also chose it on its list of top 10 scientific breakthroughs in 2015, and had these rather telling statements about these revolutionaries in psychology mapping out how to do science better, in particular this scary new thing, pre-registration, and then reporting the results no matter what. So this is open science and the efforts of psychology in replication to influence all of science, making the big time, being recognised by the world's top 2 scientific journals, Nature and Science, as being at the forefront of what's new and exciting and important in how we do science. Of course, this has led to lots of soul-searching. Here's a noted statistician lamenting that it looks like the research literature published before open science came along has a real question mark over it. Of course, much of it will be absolutely fine when replicated, but we just don't know where those effects are that won't stand up to replication unless we try. The American Statistical Association made its first ever official pronouncement on any statistical issue early in 2016 when it made a statement about the p-value. It was developed over many months by experts around the world, and they actually agreed on this wide-ranging statement about what the p-value tells us and what the shortcomings are in how it's being used. And here we have a pithy statement of one of the main messages of the book, that p less than 0.05 is really not the way science should be done. The president of the ASA talked about the post-P less than 0.05 era. Scientific argumentation is not based on just a p-value, but we need to pay attention to effect size and confidence intervals. We're thinking of evidence as being continuous, certainly not dichotomous. If you follow all these arguments, then you are right up with the best research practice. So here's the summary once again. I won't go through it yet one more time, but we mentioned just a couple of very recent developments, and there will be more. They're coming out month by month. One was pre-registered review. The idea is when you get down to finishing step 4, you've got a terrific plan for your study, and you're about to do the real time and effort of running it, collecting data, and that's a good moment to get some expert input. Some adventurous journal editors are saying, right, send us your plans before you pre-register them. We will have them reviewed by experts and we'll give you feedback. And perhaps after you've revised them, if we reckon they're good enough, the scientific question is sufficiently interesting, and your proposed methods and measures are sufficiently promising, then we will accept your paper in advance. And then it will be published, subject to just that you do in fact follow the plan and that you do finally describe it very fully, whatever results you get. Now that's revolutionary for a journal to accept a paper before the data are even collected. But it may be the way of the future. And then our second little example is a number of projects being set up to encourage student groups, maybe yours, to work on projects together, perhaps with other groups around the world, maybe on replications. If your proposal is approved, then you can run it, and it will go into a meta-analysis of a number of studies perhaps from around the world that follow up on some interesting published research. The Collaborative Replications and Education Project is one very promising one, and it might even be able to give you a little bit of money to help you with your research expenses. And so that's open science, developing strongly and mapping out how science needs to be done. Yes, even round the world.